Hello, welcome again. We are covering GATE Aerospace Engineering syllabus. The section 1 is Engineering Mathematics and core topic is linear algebra. So in this, the last topic is eigenvalue and eigenvector. So to understand eigenvalue and eigenvector, first of all, we will take vector. Okay, so vector is any quantity having n components. Okay, or any quantity having n component is called a vector of order n. So in a linear equation, a11 x1 was there plus a12 x2 was there. Okay, so coefficient in these linear equations or the elements in row or column matrix will form a vector, or all the elements in a row matrix or column matrix will form a vector. Okay, and any n numbers x1 x2 to xn written in a particular order is a vector. Okay, so vector is any quantity that has n components, okay, or number of components to define it, then it is vector. So vectors are vectors may be linearly dependent or linearly independent. Okay, so what is linear dependence? So the vectors x1 x2 up to xn is said to be linearly dependent if there exists lambda 1 lambda 2 up to lambda n. So these quantity are one of these quantity or two of these quantity or three of these quantities can be zero, but all are not zero. Okay, so and they form equation like that: lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 up to lambda n xn is equal to 0. So this is the linear equation. Okay, and lambda 1 lambda 2 lambda 3 and lambda n up to lambda n are non-zero except 1 or 2 or 3, but there will be one non-zero element. Okay, so if no such member other than 0 exists, the vector is said to be linearly independent. If all the members are 0, okay, lambda 1 lambda 2 lambda 3 0, then it is linearly independent. For it to be linearly dependent, one of them should be non-zero. Okay, if all are 0, then it is linearly independent. Suppose lambda 1 is not equal to 0. Okay, and lambda 2 can be 0, lambda 3 can be 0, but lambda 1 is not equal to 0. Then lambda 1 x1 can be taken on this side, then it will be minus lambda 1 x1. Okay, and if we divide minus lambda 1 by whole of this equation, then suppose the new equation is x1 is equal to mu 2 x2 plus mu 3 x3 up to mu 1 xn. So this is your linear combination of, now it is the x1 is linearly dependent upon x2 x3 x up to xn. Okay, so this is your linear dependence.